Yes, one thing I like to inform you, nowadays we are saying it's a pandemic situation, horrible situation. Yes, it is absolutely. But yesterday I was with viral infection. Maybe whatever the people say, the Omicron symptoms and all those were there, but only one day. Within one day, one can get cured. Okay, little effect remains, but without any kind of medication also. I'm not saying that don't take medication. Do what the follow the instructions given by the physician. But these are the it's a viral, no? Our body has to only find the solution. A thorough rest, proper mentality that may certainly help to great extent. It's a my experience that I am sharing with you. Nothing to worry more. Means in case you also come across such kind of the infection, then don't worry. Only proper mindset and rest. That's a good medicine. That is my view. After all, if additional medicine if you take, then also will do. But don't be panic. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Means one day, means almost 12 to 18 hours rest is what sufficient. Yeah, good, good. Students, last time I discussed the water. The basic aspects I made clear. And I asked you to study the cations in aqueous medium or ions in the aqueous medium. Have you studied?
Yes.
Shubham said, Saurabh texted here, Prathamesh texted, three students are. Okay, others are not saying, but they are honest. I like that. Mandar also said yes. If no, then say no. No, that's a clear cut honesty. Yes, Siddhi, what about you? Shilpa, Chirag, Gaurav, Jelina, why don't you reply? Okay. So I'm coming, Mandar, to ask the questions. But meanwhile, I want reply from others also. If no, then say no. I understand. Okay, this time you not found the time. Next time you will find time. But your no will help you a lot to progress later. But now, suppose if you are habituated to not to reply, then that will be obstacle for your progress. Yes, Siddhi, are you understanding? Yes, Jelina said now. Okay, no. Okay, no issue, Jelina, but you said no. It's good. Shilpa has not replied. Gaurav has not replied. Yes, Shilpa also said no. Siddhi said no. Okay, okay. Means somebody was waiting to say something no. Then one said no, others have said followed. Others followed. Chirag, what about you? Chirag, are you online? Gaurish, have you studied the things which I asked last time? Study the behavior of ions in the aqueous medium, say especially cations.
No, sir.
Okay, good. Chirag, are you there? Okay. I prepare one question to you and I will follow one website that's a menti.com. I am asking one question to you. Please answer. Click on that link and answer the question. If you have answered, answer this question also. I'm finding link is same, but is the question different?
Sir, I am getting same question.
Same question you're getting. No, yeah, actually it's
Yes,
showing
sir.
for this. Just wait. Because link is same. If you scroll down, are you getting second question?
No, sir.
No.
No, sir.
I need to present other presentation. Okay, other students, did you get the answer for the first question? Only 8 students have answered here. Total 10 students are there. 8 students have answered. See, 2 students have not answered. If you not found the link, ask me. I'll send the link again. See, it is a link. Answer the question. Meanwhile, I am preparing second question. Yes, I think the new link is there because of that we'll get a new question. In spite of answering, students are preferring to quit. It's not fair. Siddhi, have you answered the question?
Yes,
Siddhi.
sir.
Okay, now second question is posted. See, just answer second question also. Chirag, have you answered?
Yes, sir.
Okay, now second question also answer now. Why is it taking more time to reply?
Hello, sir.
Yes, Siddhi.
सर सेकंड क्वेश्चनची लिंक माझ्याकडे दिसत नाही इकडे.
Okay, now see, I have sent it. Only 6 students have answered. Siddhi, have you answered second question?
Yes, sir.
You know who has not answered? Okay, now all have answered. Okay, let me present the screen so that you also will come to know your responses. See, it was our first question. Can cation provide acidity to the solution? Yes, absolutely yes. And at that time, 9 students were there. All are saying absolute. Now, why cation do provide acidity to the solution? We can think on that. Second question asked was interesting answers are there. See, can cation be neutral in water? 2 students are saying yes, and 5 students are saying no. Means here your understanding is needed to improve. If you know actually what happens during the cation entry in the water or anion entry in the water, then such ambiguity, such differences in the opinions or answers will not be there. It has occurred because you are not aware about the concept. So Mandar raised the question at the beginning only. I answered that question. But remember, students, your work, your study, your learning, your reading is more important. Shall I answer the question asked by Mandar?
Yes, sir.
Okay, okay. One has replied orally and others are replying in the chat box. A question by Mandar is about the cations in water. Let cations be there or anions be there. Concept you have to understand. Concept in the sense you have to understand water in terms of the reaction or behavior with foreign ion. One by one, you need to help me. What is the formula of water?
H2.
H2.
So I represent in structural way. Likewise, I hope there will be no ambiguity about this structure. It is an angular structure. Lone pairs are present. Oxygen is more electronegative, so will govern partial negative charge, and hydrogens will govern partial positive charge, about which there should not be any problem. Am I right?
Yes, sir.
Yes, sir.
Yes. So water
Yes, sir.
in aqueous medium, how does it behave? It behaves like a dipole. So it's like a consider a structure. Here oxygen is there, it's bearing negative charge, and here positive charges are there in the water. So when any other new species do come in the aqueous medium, say if I add a positive ion, a positive species is here, it is carrying one positive charge. Then water is with two kinds of orientation. One orientation pointing its negative pole. Here negative charge is a one. And other orientation pointing its positive pole. That's a water. Here positive and positive. What do you think? What is likelihood? What is favorable? Pointing negative pole or pointing positive pole? Cation is there. So water will approach towards cation pointing its positive poles or pointing negative pole.
Negative pole.
Why?
Positive, negative attraction.
Yes, absolutely. A bit natural, positive and negative, there will be the attraction in case of classical mechanics. In case of particulate mechanics. In case of wave mechanics, thought concept is there. Wave concept is there. The situation is different. Positive is attraction. Molecular orbital theory that you have studied, there the concept is different. Here I am talking about charges. So positive pole and negative pole, there will be attraction. And why should there be attraction? Attraction gives what? Attraction gives, or because of attraction, what results? Complete now. Because of attraction,
Stability.
right, stability, and that's the purpose, no, of life of these chemicals and our life also. We want happiness, we want stability. Molecules, ions, atoms also want the same. So by means of attraction, there will be stability, but never they run behind only attraction. If repulsion is there, they cope up. They see how can be the more attraction. So it is sure now, if any cation remains in a aqueous medium, cation remains, so I'm representing it as a positive charge. Let it be the 1 positive, 2 positive, 3 positive, any it may be. That water will approach through oxygen end, pointing negative pole. Not only one water, many water molecules will approach pointing negative end, that is oxygen end. Up to here concept clear?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
They have just came closer, but mingling among them, more attractive development among them have not taken place. So this simple process of surrounding the water molecules to any ion, maybe cation or anion, is called as, yes Mandar, what can we say for that? Your question.
Hydration.
Right, that is hydration. Hydration. I give you now the proper definition further. Hydration, we say that only water molecules surround. It is true. It is a solvation process in that way. But result of that also is considered as a hydration. Sometimes because of hydration, that metal, say if I consider Fe plus 3, will combine with 3OH and will form FeOH thrice plus other H2 molecules are there. So this resultant compound is because of hydration or hydrolysis. Water molecule break and then what the attack. So that also we considered as a result of hydration. So few were. Next year you will study acid hydrolysis and base hydrolysis. So it is related to water or part of water. Then question will be H3O plus, how it can be part? In auto ionization, it is a part. When we decide the pH, at that time actually H3O plus plays the role, not H plus. H3O plus is formed from H plus, it is different. So water or part of water, those things we consider in the hydration. Now, why the part of water occurs? When the part of water will involve in the reaction, here you need to understand the chemistry between interaction. Chemistry of interaction. Again, I represent here positive ion, say is with the N positive charge. And for the sake of simplicity, I represent here only one water molecule. Same is the case for other water molecules. When water molecules surround the cation, at that time, a bit natural between this negative charge of oxygen and positive charge, there will be the attraction. As Saurabh said, positive negative attraction. So that attraction will be there. But if that attraction is powerful, then oxygen will think, see, previously I was with hydrogen as a friend. And whatever now the new thing is there is more powerful. So oxygen thinks to break this bond. And while breaking that bond, it will show its greediness. What it will say to the hydrogen? Hydrogen is poor. Whatever electron is there, no, give it to me and get out. Means up to when that water molecule existence is necessary, hydrogen was a need for the oxygen. But as soon as oxygen finds a solid attraction, powerful cation, then oxygen says goodbye to the hydrogen. Why? Because of saying goodbye to the hydrogen, oxygen will get more negative charge and this cation will exert more attraction. More negative charge, more attraction will be there. Depending upon power, that will be the situation. So what will be the result later? Students, are you understanding up to here?
So can you repeat one more times?
Yes. I'll see here. Simply water molecule when you consider, again I represent here. Simple water molecule we represent in this way. Oxygen is more electronegative, so bear negative charge. Hydrogen bear positive charge, partial positive charge. But still the two electrons are there. One electron from oxygen, one electron from hydrogen. Oxygen electron and electron from hydrogen. It is the bonding in the water molecule. Up to here, concept clear?
Yes, sir.
Yes, sir.
Yes. But when we consider metal ion, consider one metal ion or positive ion or cation, and water approaches towards that, then this attraction develops. But suppose if this metal is very powerful, who decides the power? That I will tell to you. But if it's powerful, then what oxygen will think? Oxygen will think previously I was with these two hydrogens and my electron I was sharing with that hydrogen. And now whichever metal ion is there, it is too much powerful, too much positive charge is there. Hydrogen can give only one positive charge, no? And with hydrogen covalent bonding that already done. So oxygen thinks about the bonding, rethinks about the bonding. And what oxygen thinks is a calculation of oxygen I'm saying. Suppose, means if I'm oxygen, then what I will think? Suppose if I ask this hydrogen to get out, what will happen? Hydrogen will ask electron. No, hydrogen doesn't have that much courage. Hydrogen have not that much electron negativity as I am with. So I need not to give my electron. And on the other hand, I will get electron from hydrogen also, and this hydrogen will be lost. What will be the result? I will govern more negative charge. More negative charge. Previously, partial negative charge was there. Now, perfectly negative charge plus partial charge is there. That's a different. So, perfect additional negative charge will be there. That's the advantage. I will think as oxygen. How will it be advantage? Because of my more negative charge, metal ion will love more. Metal ion will be attracted more. Metal ion will come more closer. There will be the more attraction, more stability, more satisfaction. That's the calculation of oxygen. Could you able to understand what I am saying now?
Yes, sir.
Other students?
Yes, sir.
Yes, sir.
Yes. So at first instance, what can we think or what can we find? Water was H2O. Now water is OH. Water became OH because H plus is lost. When it is possible, if this metal ion is powerful, then only it is possible. Is it clear?
Yes, sir.
Yes, sir.
Now let us consider metal extremely powerful, highly powerful metal. If I consider M plus N charge is there and highly powerful metal ion. In such cases that OH minus is there, no, here OH minus and more attraction was there. What oxygen will think again is a business of oxygen. What logic was applied to this hydrogen here? Same logic will be applied here. That oxygen will think, why not to remove this hydrogen also as I removed previous hydrogen? What will happen because of that? I will get electron of that hydrogen. What will happen because of that? I will get extra charge. What will happen because of that? I will get more attraction with the metal, and this hydrogen also it is ready to give, resulting metal here at the center, and around that there is only O minus 2. O minus 2 is from water actually. So it will form oxide. Before that, what will it form? Hydroxide. Before that, what was here the situation? Only water molecules surrounded. That simply we say as a hydration. Result of hydration is a first. This is the first result where you are getting only water molecules surrounded. It is a second result where hydroxide formation. It is a third result. Sorry. This is a third result where oxide formation occurs. All these depend on power of metal ion. Therefore, students, I asked you one question. That question was about the cations can render acidity or not. Everybody said answer as what? Yes. Cations do render the acidity. Yes. Previous question was asked there, and absolutely. Had I shown you that report? Yes. Just wait. This slide is not opening. Yes. All have said yes. Cation can provide the acidity. Absolutely. It is true. But what about this? Can cation be neutral in water or in aqueous medium? Sorry, again the same result. Why your replies are not here? This same question was there, no? Okay, I find other way to find that. Such question was there to you know. So answer is expected here. Same question, how is coming? Yeah. So I asked the question to you: can cation be neutral in water? Then many of you are saying no. But in true sense, if cation is not powerful, then only gathering will be there. Gathering of whom? Water molecules. It's a solvation, or you can say hydration. But if cation is powerful, then hydroxide form metal. But who is coming out? Please reply. When hydroxide forms, who is coming out? When water forms hydroxide, who comes out? Students, are you understanding my question?
No, sir.
See, hydroxide formation possible when hydroxides are obtained. Three stages I told to you. First stage, simple water surrounding. There, nobody is coming out. Second stage, hydroxide formation. There something is coming out. What is that?
H plus.
Right, H plus. That H plus is responsible for what? Acidic behavior or basic behavior?
Acidity.
Acidic behavior. Therefore, we say cations can render acidity to the solution. can render, it depends upon its power. And other twisting question was asked, this one, can cation be neutral in the water? Yes, it is also possible. There's a first behavior of water, only just a gathering. Nothing came out, but only just simple attraction. That is what the neutral situation. Cations can be neutral in water. Cations can be acidic because of H plus ion coming out. And cations can be more acidic if cation can ask oxygen to furnish further two, that's whatever hydrogens are there, those hydrogens means total two hydrogens, means it can form oxides. O minus 2 will combine with metal. So oxygen, it came with as a water, means H2O, and when that metal ion come in contact with water, then that H2O is converted to only O minus 2 and H plus are outside. So how many H plus are coming out in the formation of oxide from one water molecule? How many H plus are furnished during oxide formation? No, I am not understanding. Why are you not understanding? Where is the problem, student?
Repeat, sir.
Okay, I repeat, just wait. See, I had shown you, I told you, see, a simple form of water, such dipole separation is there, still water is united, still water is together, but water wants stability and more attraction it develops. With whom? Cation. For that I have shown you first step, where just the water molecules surround the cation. Only simple attraction is there. This is the first form of what the water. Simple attraction is there. But slowly, if metal ion remains powerful, oxygen behavior changes. Calculations of oxygen changes. And what oxygen does? Oxygen removes one hydrogen and forms hydroxide. If metal ion is further more powerful, then it can form oxide. My question is, how many H plus will be removed? How many H plus will be removed while formation of oxide? See, when formation of hydroxide, this one H plus is removed. Then formation of oxide, how many H plus are removed?
2.
Right, 2H plus, total 2H plus are removed, and these H plus will be responsible for acidity of that solution, acid behavior of that solution. So if there is oxide formation, then suddenly acidic conditions will be more, pH will be less. It is understanding of behavior of ions in aqueous medium. So my second question was regarding this. Can water molecule, can cation be neutral in the aqueous medium? Yes. If such situation is there, simple approach is there. If cation is not more powerful, then yes, it will not ask any H plus to furnish out. Water will not bring additional H plus out. Then acidity will not be there. There is no question of basicity. So such cation can be neutral. pH also matters there. See, suppose if the OH minus is the result, then here it is what the acidic. Different categories of cations are there. If such results are there, then it can be strongly acidic. So different levels of the cations also you will come to know, and that categorization we are doing on the basis of pKa value, and the pH will be for the understanding purpose. pKa means, this K means dissociation constant for that acid. P means power of dissociation. Means indirectly you will understand the power of the acid. Yes, students, are you understanding what I am saying?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yes. So today I discussed the question asked by Mandar. What is meant by the hydration? See, hydration is just the surrounding the water molecule. Water molecule, how is it? The negative charge on oxygen and positive charge partial on what? The hydrogen. So simply I represented in this way as a two poles. And when it surrounds the cation, then chemistry changes as per the power of metal ion, because everybody wants stability, and during govern the stability the changes are there. When simple water molecule surrounds, it's like a neutral. But there are ample of evidences, ample of examples where water doesn't remain water. Water doesn't remain H2O. Water converts to OH minus. Water converts to O minus 2 because of power of the metal ion. So when it is a powerful, first step occurs that this bond can what? Dissociate because of the calculations of the oxygen with interaction with the metal ion. When it is a powerful, then one H plus can be removed out and hydroxide can form. Solution becomes acidic. When metal ion is more powerful, second hydrogen also is furnished out and solution becomes strongly acidic. It's a concept of today's learning. Mandar, did you get the answer for your question?
Yes,
Yes,
sir.
sir.
Other students, question asked by Mandar and answer I provide. Is it clear?
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Yes. So for next lecture, I am giving you the homework. Different cations show different acidic behavior. What are the factors on which the acidic behavior depends? Maybe charge, maybe size, maybe electronegativity. Different factors are there. Work on those different factors and categories of cations. Somewhat large syllabus I am giving because days also are more. And categories of the cation. Neutral cation is non-acidic cation. It's not say neutral, non-acidic cation. Feebly acidic, moderately acidic, strongly acidic, very strongly acidic. Likewise, categories of the cations are there. Just study them, and next time we will have the discussion. Today, few students were with no preparation, but I suggest them, yes, you also do involve in the preparation. Let me know, are you interested to prepare or not? Are you interested to study or not? That's my question. Yes, Saurav, I'm saying, are you interested to study or not? That is a question.
Yes,
Yes,
sir.
sir.
Yes, study now. See, you have to work.
Yes,
Yes,
sir.
sir.
What I can do, I can give you the path. And wherever problems are there, I am there with you. But if you are not working and you're saying no, all problems are there, nobody will help you. You are not a student. So work, read. I like Mandar asked the question. I answered that question also. Those things not directly in the books, but additional knowledge is what provided. Yes. What I am asking you to do up to the next week, next lecture. First point, know the factors which are responsible for acidity of the cation. And second point, categories of the cation, types of cations. Is the task clear?
Yes, sir.
Yes, sir. Yes, sir.
I hope your study material, if study material is not there, then so bring it to my notice. We will see what can be done to get study material. But study material is necessary. You have to get that. Okay. Okay. Shall we stop now?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, student. I declare here today's session is over. Please quit.